Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannon, and this is Minute Math. Today, we're going to learn about differentiation, and we're going to apply the product rule. We're going to differentiate each function with respect to x. So if I was given this function, y equals negative x to the third times 3x to the fourth minus 2. Well, if I want to apply the product rule, we have a little rule right here that if I take the derivative, I have my two functions here, my first one and my second one. We're going to take the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay, and that's our rule here. So dy dx is equal to the first function, first part right here, negative x to the third, times the derivative of the second. So the derivative of what's in the parentheses here is 12x to the third, right? I would apply the power rule there, plus the second one, 3x to the fourth minus 2, times the derivative of that, right there, the first part, right? And that's a negative 3x squared. Okay, so now that we've applied the product rule, we need to simplify this. So let's distribute or multiply that out. So dy dx, negative x to the third times 12x to the third. Well, when we multiply the x to the thirds, we add the exponents and we multiply the coefficients up front. So we have a negative 12x to the sixth plus, multiplying these out, right? Well, we distribute the negative 3 across. So our negative 3x squared, so negative 3x squared times 3x squared is a negative 9x to the sixth plus, we distribute that negative 3 to both parts here, plus with a minus 2 is a positive 6x squared. Now I can simplify this and combine my like terms. And so let's go combine the negative 12x to the 6 and negative 9x to the 6. So we have dy dx here. Negative 12x to the 6 plus negative 9x to the 6 comes out to be negative 21x to the 6 plus 6x squared. And there we have our final derivative. Dy dx is equal to negative 21x to the 6th plus 6x squared. F of x is equal to x squared times negative 3x squared minus 2. Okay? Well, if I want to apply the product rule, I need to see that I have my function in two parts. This is f, first part, and this is g. Okay, f being x squared and g being negative 3x squared minus 2. Now to apply the product rule, because there's multiplication going on as a product rule, f prime of x, when I take my derivative, I have the first part, let's go apply it right here, keep my original function, first part, f, x squared, times the derivative of the inside of this parenthesis here, so that's negative 6x, right? Derivative of that, this power comes down, we apply the power rule there, negative 6x, and then derivative of negative 2 is 0. So negative 6x there, plus, what's in the parenthesis, negative 3x squared minus 2, times the derivative of the first part, which is just, well, derivative of f is 2x, right? Because f was x squared. Now at this point, we've taken the derivative. So now we need to simplify. So we have f prime of x here. Let's simplify that. Well, x squared times negative 6x is a negative 6x to the third, plus distribute this 2x across. 2x times negative 3x squared is negative 6x to the third. 2 times negative 2 is a negative 4x. Let's combine our like terms. We have the same exponent, same degree there. So we have, f prime of x is equal to negative 6x to the third plus negative 6x to the third is negative 12x to the third minus 4x at the end, and there we have it. We have our derivative. F prime of x is equal to negative 12x to the third minus 4x. Y equals, parentheses, negative 2x to the fourth minus 3, close parentheses, new parentheses, negative 2x squared plus 1. Well, let's go label which one's my f and which one's my g. First one's f, the negative 2x to the fourth minus 3, and this second one, negative 2x squared plus 1, is my g. So now I want to apply the product rule. Product rule states, I'll take my dy dx here. The first part, f, negative 2x to the fourth minus 3, times the derivative of the second. Derivative of g is negative 4x, right? With only the plus 1, because that gets eliminated when we take the derivative of it. Then the 2 comes down and use the power rule. Plus the second, g, negative 2x squared plus 1, times the derivative of the first, take the derivative of the first, negative 8x to the third. That's it. So now that we have our derivative, we've taken the derivative right here, okay? So now we need to simplify that. So let's go simplify it. We do a lot of distributions there. So we multiply the negative 4x, or dy dx here. Multiply the negative 4x out. Negative 4x times negative 2x to the fourth is a positive 8x to the fifth. Plus negative 4 times negative 3 is a positive 12. And then the x is there. Plus, distribute the negative 8x to the third around. So negative 8x to the third times negative 2x squared is positive 16x to the fifth. And multiply, again, negative 8x to the third by 1, and we have a negative 8x to the third. Okay? Now we look, can we simplify anything and rearrange and have our highest degrees first? Highest degrees are 5, so we can combine them. So our dy dx here. Well, 8x to the fifth plus 16x to the fifth, I would have to say is 24x to the fifth. Plus, well, or minus, the next one's going to be the 8x to the third power. So we minus 8x to the third power. And then the last term here is plus 12x. And there we go. We have all parts there. We have our derivative, which is 24x to the fifth, minus 8x to the third, plus 12x. F of x is equal to, parentheses, 2x to the fourth minus 3, new parenthesis, x squared plus 1. Well, to apply the product rule, we have two functions that we're multiplying together, or multiplying against each other, okay? Our two functions here, we can label as f and g. So I'm going to label this one f, and this one my g, my second one, okay? So when I take the derivative, f prime of x of that, okay, I'm going to apply the product rule. Product rule states f, which is 2x to the fourth minus 3, times g prime, which is 2x, derivative of our function g, plus g, which is x squared plus 1, times f prime, which is 2x, well, 2x to the fourth minus 3, derivative of that is 8x to the third, okay? Now I need to distribute. So when I distribute across here, prime of x here, let's go multiply the 2x times the 2x to the fourth, which gives me 4x to the fifth. 2x times a negative 3 is a negative 6x. Again, now we do the same thing with the 8. The 8x to the third. 8x to the third times x squared is 8x to the fifth. And then 8x to the third times positive 1 is a plus an 8x to the third. So now we have our derivative, a little more simplified, but now we want to have the highest degrees first. Let's go write it out nice and neat. So let's go simplify, adding our highest degrees together and reorder this using the commutative property. So we have f prime of x is equal 4x to the fifth and 8x to the fifth are my highest degrees. We add them together, we have 12x to the fifth. Next highest degree was 8x to the third, so we have plus 8x to the third minus 6x. And there we have it. Our final answer, f prime of x is equal to 12x to the fifth plus 8x to the third minus 6x. F of x is equal to 5x to the fifth plus 5 times parentheses negative 2x to the fifth minus 3. Okay? Well, what I want to do now is I have my two functions, right? I see those two functions. I'm going to label the first one f, the second one g. So I have two functions that are being multiplied, and now I can apply the product rule. So I apply the product rule, f prime of x. Let's follow it, it's written right here. F 5x to the fifth plus 5 times g prime, derivative of g, which is negative 10x to the fourth, plus g, negative 2x to the fifth minus 3, times f prime, which is 25x to the fourth. Okay? So from there, I need to simplify, so I'm going to distribute out here. So we have f prime of x, distribute the negative 10x to the fourth, so negative 10 times 5 is negative 50, And the x to the 4th times x to the 5th is x to the 9th. To distribute the negative 10 times the 5, which is negative 50, x to the 4th. Plus, distribute the 25, x to the 4th out. So we have plus a negative 50, x to the 9th. And then negative 25, or 25 times negative 3 is a negative 75, x to the 4th. So now we want to combine our like terms. So I see the negative 50x to the 9th and negative 50x to the 9th. So there, and that's the highest degree. So we have f prime of x here is, well, combine those two together, negative 100 x to the 9th. And then we have negative 50x to the 4th and a negative 75x to the 4th, which is a negative, or subtraction, 125x to the 4th. And there we have our answer. F prime of x is equal to a negative 100x to the 9th minus 125x to the 4th. F of x is equal to negative 3 plus x to the negative 3rd times negative 4x to the 3rd plus 3. Okay? Well, to apply the product rule, I need to have two functions that are being multiplied together, which I have. I'm going to label the first one here, negative 3x, 3 negative 3 plus x to the negative 3rd with f, and the second one here, negative 4x to the 3rd plus 3 with g. So now I have my two functions, they're labeled, I can apply the product rule. Okay? So our product rule states f, we write, it's written right here, and once we take the derivative, it's f, so negative 3 plus x to the negative 3rd, times g prime, which is negative 12x squared, plus g, all right, negative 4x to the 3rd plus 3, times f prime, which is negative 3 plus, that's not the derivative, I'm rewriting f there. I need to take the derivative. Remember your own rules, John. Okay? Well, it's not my rules, but derivative of that is just a negative 3, I guess it was. This negative 3 is canceled, the negative 3 comes out exponent, x to the negative 4th power. Okay, I guess I could have kept it. All right. So we need to distribute now. Distribute this out. So f prime of x is equal to distribute negative 12x to the 2nd power times negative 3 is a positive, what is that, 36x squared. Negative 12 times negative 12x to the 2nd power times x to the negative 3 power is negative 12x to the negative 1 power. Okay. Plus, here, distribute the negative 3 across, or negative 3x to the negative 4. So we have negative 3 times negative 4 is a positive 12. And then we have x to the negative 4th times x to the positive 3rd gives me x to the negative 1. Plus, distribute the negative 3 across again. Negative 3 times 3 is negative 9. And that's x to the negative 4th power. Okay, so let's simplify this. Well, let's go combine our like terms, put our highest degree first. Highest degree is x squared, I see. So we have f prime of x is equal to 36x squared. Then we have a negative 12x to the negative 1 and a positive 12x to the negative 1. They cancel each other out, right? So we just get 0 there. And then we have subtracting 9. Well, 9 to the negative 9 times x to the negative 4th power. Let's make that positive exponent. So we have negative or minus 9 up top over x to the positive 4th power. And there we have it. Okay? We have our derivative. F prime of x is equal to 36x squared minus 9 over x to the 4th. Y equals parentheses negative 2x to the 4th plus 5x squared plus 4. And we're going to multiply that by a second parenthesis here of negative 3x squared plus 2. Well, to apply the product rule, I have to have two functions that are I can find two functions that I'm multiplying together, which we have. We have our two functions here, this parenthesis and that parenthesis. First one, negative 2x to the 4th plus 5x squared plus 4. I'm going to label that as my f. And negative 3x squared plus 2, I'm labeling that as g. Okay? So when I apply the product rule, when I take my derivative, dy dx, I'm going to take my f, negative 2x to the 4th plus 5x squared plus 4, and I'm going to multiply that by g prime being negative 6x, taking the derivative of our g, plus g, which is negative 3x squared plus 2, times my f prime comes out to be negative 8x to the 3rd plus 10x. Okay? So now once I have that, I need to simplify this. So to simplify it, I need to distribute my parts out. So we have dy dx is equal to, let's distribute, negative 6x times negative 2x to the fourth is a positive 12x to the fifth, plus negative 6x times 5x squared is a negative 30 x to the third, and then negative 6x times 4 is a negative 24x. Let's make that a plus a negative, why not? Okay, negative 24x. So now I have the next part here, plus, okay, here. Let's go distribute. Well, let's go negative 3 x. Now remember, there's two parts here, right? Two parts for each one. So we have to make sure we get all of them here. Negative 3x squared times a negative 8x to the third is a positive 24x to the fifth. Negative 3 x squared times 10x is a negative 30x to the third. 2 times negative 8x to the third is a negative 16x to the third. And 2 times 10x is a positive 20x. So now we got to find our like terms. My two highest and basically find our like terms, combine them together, highest degrees first. Highest degrees I see are to the fifth power. I have two of them. So when I simplify this, dy dx, and it might be good to like mark once you've combined two of them together. 12x to the fifth plus 24x to the fifth is 36, positive 36x to the fifth. So I'm going to mark these two to show that I've brought them down. Okay. Then the next highest degree I see is the third power. I have 3 of them. 1, 2, 3. Okay, 3 of them to the third power. So to combine them, well, negative 30x to the third plus negative 30x to the third is negative 60x to the third, right? Plus a negative 16. Okay, so 60x to the third, negative 60x to the third plus negative 16x to the third is negative 76x to the third. We got these 3. And lastly, we have the last two here are just x's. Negative 24x plus 20x is a negative 4x. And there we have our final answer. Dy dx is equal to 36x to the fifth minus 76x to the third minus 4. Y equals, parentheses, x to the fourth plus 3 times a negative 4, in second parentheses, x to the fifth plus 5x to the fourth plus 5. Okay? Well, my first thing I want to do is I notice that there's two parentheses here, two functions. So I'm going to label them so that I can apply the product rule, f and g. And there's multiplication. So now we can apply the product rule between the two. So we have dy dx. Our derivative here is to apply it, product rule is written right there, f, which is x to the fourth plus 3, times g prime, so let's take the derivative of this, negative 20 x to the fourth plus 20 x to the third, and then there's no plus 5 because that's eliminated, so that's our g prime, plus g, which is negative 4x to the fifth plus 5x to the fourth plus 5, times f prime, which is 4x to the third. Okay, big and written out here. So now we need to distribute, make sure we have all parts going on here, so is give me a little more space, dy dx here. So we distribute x to the fourth times a negative 20 x to the fourth. Okay, that means we have a negative 20 x to the 8th power. X to the fourth times 20 x to the third is 20 x to the 7th power. 3 times negative 20 is a negative 60 x to the 4th power, and 3 times positive 20x to the third is 60x to the third. Okay, now we do the same thing here, so distribute. So I'm going to do it this way. Negative 4, ooh, sorry, my voice just cracked. Oh, it's like I'm back in high school all over again. Negative 4x to the fifth times 4x to the third is negative 16x to the 8th. Again, we distribute, already did that one, sorry. Distribute the next one here. 5x to the fourth times 4x to the third gives me 20 x to the 7th power, and then 5 times 4x to the third is 20x to the third. Okay, so now we need to combine our like terms and our highest degrees first. So dy dx here, let's get our final derivative here. I see our highest degrees are to the 8th power, so I combine the two with the 8th power. I have negative 20x to the 8th, and the other one I see is negative 16x to the 8th. So we have combine them together, we have negative 36x to the 8th, right there. Now we have to look at our x to the 7th powers. So we have 20x to the 7th and 20x to the 7th. Combine them together. We have 40x to the 7th. I'm going to put a dot again underneath, showing that I've used those. Okay. The next ones, the highest degree I see is to the 4th power. There's just one of them, right? Yeah, just one of them. So I'm subtracting 60x to the 4th. Brought that down. And lastly, the last two are x to the 3rd power. So I have 60x to the 3rd and 20x to the 3rd combined together to get 80x to the 3rd. And so we have our final answer here of dy dx is equal to negative 36x to the 8th plus 40x to the 7th minus 60x to the 4th plus 80x. Y equals 5x to the 4th minus 3x squared minus 1 in my first parenthesis. Second parenthesis, negative 5x squared plus 3. Well, I see I have two functions that are multiplied together. I can label the first one f and the second one g. And this allows me to really see the product rule here. So if I find my derivative, dy dx, I have to apply the product rule. Okay? Product rule states the first part, f, 5x to the 4th minus 3x squared minus 1, times the derivative of the second, which is 10x right there. Then we add the second part, g, negative 5x squared plus 3, times the derivative of the first, which is our f here, which is 20x to the 3rd minus 6x. Okay, so now I need to distribute. So let's go simplify. We've already taken our derivative, so here's the derivative where it exists. Now we need to simplify. So at this point, the rest is just algebra. Negative 10 times 5x to the 4th is negative 50x to the 4th. Negative 10 times a negative 3x squared is a positive. Oh, sorry, x to the 4th power. Oof, I got ahead of myself. We add the exponents, it's the 5th power. Negative 10x times the negative 3x squared is a positive 30x to the 3rd. And the negative 10x times a negative 1 is a positive 10x. Now we're adding it together, distribute the next parts. Now we have two parts here, so make sure eventually we're going to have 4 terms. Okay, so multiply here, negative 5x squared times 20x to the 3rd is a negative 5 times 20 is 100. 100x to the 5th. Negative 5x squared times the negative 6x is a positive 30x to the 3rd. 3 times 20x to the 3rd is 60x to the 3rd. And 3 times negative 6x is a negative 18x. Okay, so now we have our long, big derivative. Let's go simplify. Let's combine our like terms and put our highest degrees first. So dy dx here. Let's go simplify this. I have my highest degree I see is to the 5th power. So negative 50x to the 5th and negative 100x to the 5th give me a negative 150x to the 5th. And I put dots underneath showing that I've simplified and brought them down. The next one here, I have 30x to the 3rd and 30x to the 3rd and 60x to the 3rd. So x to the 3rd is my next highest degree I see. There's no x to the 4th. Great. So 30x to the 3rd plus 30x to the 3rd is 60x to the 3rd plus 60x to the 3rd is 120x to the 3rd. So I applied these down. Okay. So the last ones I have is just 10x and negative 18x, which is a negative 8x when I combine them together. And there we have our answer, our derivative, which is dy dx is equal to negative 150x to the 5th plus 120x to the 3rd. Make sure that looks like a minus 8x. Function f of x is equal to negative, first parentheses, negative 10x squared minus 7 times the 5th power, or 5th root, of x squared plus 9 times my second parenthesis here, 2x to the 3rd plus 4. Okay? I did really make it look nicer. That's a 2. Not 1. Okay. So I have two functions that I'm multiplying together. I'm going to label them f and g. Okay? So I have f and my g here. Okay, I have two functions that are being multiplied together. I can apply the product rule. So when I apply the product rule, f prime of x, I rewrite my f. And when I rewrite my f, I don't like to have roots. So I want roots with over a variable, and squaring it and stuff. I'm going to rewrite that to be a fractional exponent. So we have negative 10x squared minus 7 times x, and here it's to the 2/5 power, okay, plus 9, times the derivative of our g function, which is 6x squared, plus our first function, 2x to the third plus 4, times the derivative of the second, all right, times the derivative of the first, which is up here, and I'm kind of looking here when I deal with my fractional exponents so I can see what's going on. Derivative of that is negative 20x squared, or x, sorry, oh my goodness, 20x minus, well, 7, the 2/5 times the 7 gives me a 14/5, that's 14/5 x to the negative 3/5 power, and that's it, right? Because the 9 gets eliminated there, okay? So now I need to simplify. To simplify, I need to distribute. So right now we already have our derivative. It's nice and crazy. Let's distribute the things out so we can simplify it. So 6x squared times a negative 10x squared is a negative 60 x to the fourth. 6 x squared times negative 7x to the 2/5 power, okay? That's a negative 42x. Now we have to add our exponents. 2 plus 2/5 comes out to be 2 plus 2/5. 10. It's 12/5. 12/5 power plus 6 times 9 is 54, and that's x squared. Plus, let's distribute here again. So make sure we distribute all parts here. 2x to the third times a negative 20x is a negative 40x to the fourth power, okay? And then we have 2x to the third times 14, or negative 14x to the fifth, so we have plus and negative here. 2 times 14 is 28, so we have 28 over 5. We add our exponents, so 3 plus a negative 3/5 comes out to be, well, it's 15 over 5 there. Yeah, 15 over 5. So that's 12/5 again. So we have x to the positive 12/5 here. Okay. Then we distribute again the 4 times a negative 20. So we have a negative plus a negative 80x. And then 4 times right here, negative 14 over 5, almost 4 times 14, 28 is 2, and then we add that together, it gives us 56. So we have 56 over 5, x to the negative 3/5 power. Okay, let's do some simplification here. Let's combine our like terms. Highest degree first, okay? F prime of x, highest degree first. Highest degrees I see is to the fourth power, right? Fourth power here. So, yeah, fourth power. So fourth power, we have negative 60x to the fourth and negative 40x to the fourth. We have a negative 100x to the fourth. Combine the two right there. I don't see anything else. The fourth power. Next highest degree is actually our fraction right here. 12/5 is a little higher than second power. So we're going to combine them together. Now, if I want to combine these together, okay, let's go, how do we subtract this? Well, we have negative 42 combining together with the negative 28 over 5. So let's see if I can do that with my calculator here, because I don't feel like doing it out loud. 42 plus 28 divided by 5. It's 47.6 as a decimal there. We're going to keep that as a fraction. And so 47.6 as a fraction, 47.6 is 238 over 5. So we have a negative, because we're both negatives, negative 238 over 5, okay? And that's going to be, well, our exponent is x to the 12/5 power, so we have x to the 12/5 right there. Fantastic. So now we're going to keep on going. We got those, the 12/5 power. Next one here is the squareds. The only squared one I see is 54x squared, so we have plus 54x squared. Okay. Then from there, okay, the next one I see is just the x's, which is negative 80x. So I have that right there. And then our last term here is 56 over 5 times 56 over 5 times our x to the negative 3/5 power. And that actually should be negative. I'm sorry. Oh my goodness, that's negative because those 4 times the negative 14 there. So 14 5. I'm sorry, that should be a negative. I missed that. So by doing that, bringing that down, we have a negative, 56 in the numerator over 5 times x to the positive 3/5 power, because I don't like to have a negative exponent. And there we have our final answer. And put it in the comment section below if you caught that, if you saw that I forgot to put a negative there. But I got it at the end before we went there. I noticed, I was like, wait a minute, the 4 times, that should be a negative. Anyway, our final answer here, y equals, parentheses, 5 plus 3x to the negative 2 power, close parentheses, times parentheses, 4x to the 5th plus 6x to the 3rd plus 10. So when I want to apply the product rule, I have 2 parts here. I have one equation and my second equation. I'm going to label them f and g. So f and g. We're multiplying them together. So when I apply the product rule, I have my dy dx here. I have f times g prime. So I'm going to rewrite f here, 5 plus 3, x to the negative 2 power, and times the derivative of g prime, which is 20x to the 4th using the power rule, plus 18x squared. And then derivative, when we apply the power rule to 10, which is 0, that constant right there. Now we have to add, right, the second part, product rule is right here, g, which is 4x to the 5th power, plus 6x to the 3rd, plus 10, times f prime, which is 5, or sorry, not 5, don't have 5 as part of that derivative there, excuse me. It's the derivative, bringing down the negative 2 times 3, which is negative 6x to the negative 3 power. Okay, so now from here, we need to distribute, right, each part here, right? So we'll multiply the 5 times the 20, okay? 5 times 20, x to the 4th power is 100, x to the 4th, plus 5 times 18x squared. 5 times 18, I believe, is 90, but 5 times 18 is 90, yes. So we have 90x squared, plus now the inside, 3 times 20 is 60, and x to the negative 2 power times x to the 4th power, we add the exponent, that's x squared, plus the last one here, 3x to the negative 2 power times, okay, times 18x squared. What's 18 times 3? Oh, I'm drawing up late. 54, I should have done that. 54, so we have 54 here. And then x to the negative 2 plus x squared, right? We add the exponents when we multiply them, and it's just 0. So we have x to the 0 power, which is 1, so now we just have 54 there. Now we got to multiply this last part here. What's 4 times negative 6, which is a negative 24. X to the, we add the exponent, 5 plus negative 3 is positive 2, plus 6 times negative 6 is a negative 36. Add the exponents, x to the 3rd power plus x, or times x to the negative 3rd power is x to the 0 power, which is 0, leave it b, plus 10 times negative 6 is a negative 60, x to the negative 3rd power. So now we need to rearrange and put our highest degrees first, okay? So my highest degree here, dy dx here, highest degree I see is the 4th power. So we have 100, x to the 4th power. I'm going to put a dot to show that I added that together. Now we have the next highest power is x squared. So we have 90x squared plus 60x squared plus a negative 24x squared. Okay, so let's see if we can add them together. 60, the way I would look at this is think about, okay, what's 60 and negative 24? And 60 and negative 24 minus 20 is 40, 36. So we have 36x squared right here plus 90. So 90 plus 36 is 126. So we have 126x squared, combining these 3 ones that have an x to the 2nd power together. Then we have to add our constants, 54 plus our negative 36. Add them together, we subtract that, 16 is 4, 36, is 40 plus 4, 14 is 18, so we have positive 18 here. Okay, it brings 54 and negative 36 together. And then lastly, we are subtracting, the only last bit here is the negative power, negative 60 x to the negative 3rd power. And a lot of times we actually don't really write that as x to the negative 3rd power. We keep the denominator. So I'm going to write it like this as x to the positive 3rd power. So 60 over x to the positive 3rd power. And there we have our final answer. Y equals a negative 6 x to the fourth plus 2 plus 6 x to the negative fourth power times 6x to the fourth plus 7. Okay? So I can see this big function here is broken down as two functions being multiplied together. So I'm going to label this one my f and this one my g. And so now I'm going to apply the product rule when I take the derivative, dy dx here. And I'm going to take the first part, my f, and rewrite it. Negative 6x to the fourth plus 2 plus 6x to the negative fourth. But then I'm going to take g prime, the derivative of our g here. Power rule comes out, 4 times 6 is 24, x to the third power, plus, well, derivative of 7 is just 0, so we don't really need that. So we just have the 24x to the third right there. Then the plus sign's on the outside. Now we have to multiply g. So rewrite g, 6x to the fourth plus 7, and we multiply that by f prime. So we're taking the derivative of f right here. Well, 4 comes down, 4 times negative 6 is negative 24, x to the third power, subtract the exponent by 1. Derivative of 2 is just 0, don't worry about that. Plus, derivative here, negative 4 times 6 is negative 24. Combine 2 and 4 there to be like a weird looking 4. So we have negative 24 here. And that's x to the, well, negative 5 power, or negative 5th power, right? We're subtracting the exponent by 1. So at this point now we have our derivative. But I need to distribute this. So I'm going to distribute all the way across here, okay? So we have dy dx, okay? Let's take our time. Negative 6x to the fourth times the negative 24. Well, I don't know 6 times 24 off the top of my head, to be honest. 6 times 24 is 144, and it's negative because negative 6 times 24, right? 6 times 24 is 144. So we have negative 144 x to the, now we add the exponents, 4 plus 3 is 7, plus 2 times 24 is 48. So we have 48 x to the third. And then negative 6 times 24 again is a 144 plus 144. Then we add the exponents. Negative 4 plus 3 is a negative 1. So now we're separated here by the plus sign. Now we distribute over here. So let's go 6 times a negative 24, or 6 times 24 we know is 144 from 4, but it's going to be negative, so we have negative 144. And we add the exponents, that's x to the 7th power, 4 plus 3 is 7. Then, from there, we also take a 6 times the 24 here, the negative 24 there, so we have plus a negative 144. We add the exponents, 4 plus negative 5 is negative 1. Now we distribute 7 times a negative 24. Okay, now I don't know what 7 times 24 is. By 24 more than 144. And it's 168, or negative 168, right, because it's negative. X to the third power, plus the last one, 7 times 24, which we just did, is negative 168, and there's a negative as well there, so negative 168. But we had no exponent, so it's x, or no exponent by the 7, so just x to the negative 5th power. So now I'm going to rearrange, I'm going to add them together, and rearrange, basically combining my like terms and putting my highest degrees first. So when I rewrite this, I like to make it my last step here. Let's see all the ones that have the highest degree, which is to the 7th power I see. So we have negative 144 plus a negative 144. That's a negative 288. So we have negative 288 x to the 7th power. I'm going to add these two together, and I'm marking with dots showing that I've used them. Okay. Next highest power I see is to the 3rd power, and that's going to be 48 and negative 168. And that's a negative 120, I believe, between them. Yes. So we have minus 120 x to the 3rd power between these two. Okay. So 48 plus a negative 168 is negative 120, and we have x to the 3rd power there. Combine those like terms. So now I have my next highest degree, which is the negative 1s, right? Negative 1 power. And look here, we have 144x to negative 1 plus a negative 144x to negative 1 power. Those negative exponents, they don't cancel each other out, so that just becomes 0, so I don't need that. And lastly, I have this last part here, the negative 168x to the negative 5th power. So I have a negative 168, and instead of x to the negative 5th power, I'll write it over x to the positive 5th power. Let's make a positive exponent for our final answer, and there we have it. Our final answer, which is dy dx, is equal to negative 288 x to the 7th power minus 120 x to the 3rd minus 168 over x to the 5th. F of x is equal to negative 7x to the fourth plus 10x to the 2/5 power plus 8 times, second parentheses, x squared plus 10. Okay? Well, I see my big function here, I can really break down to be two littler functions, or smaller functions. The first one being f, next one g. And they're being multiplied together. Since f is being multiplied by g, I can apply the product rule when I take the derivative. So I have f prime of x here, I'm going to take the derivative, and I'm going to apply the product rule that's written right there. I repeat f, negative 7x to the fourth plus 10x to the 2/5 power plus 8, and I multiply that by g prime, the derivative of g, which comes out just to be 2x. Derivative of x squared is 2x, and the derivative of 10 being a constant is just 0. So now we have to add this to g, which is the next part of the product rule, x squared plus 10 times the derivative of f. So we have negative 7, all right, negative 7x to the fourth, we take the derivative of that. 4 times negative 7 is a negative 28. X, we subtract the exponent by 1 to be to the third power. Plus now, the 2/5 comes out up front, and the 2/5 times 10, well really that comes out to be a 4, right? The 5 and 10 kind of cancel out, giving me a 2 up there, and 2 times 2 is 4, or 2 times 10/5 is 4. So we have 4x, now we subtract 2/5 by 1, which gives me a negative 3/5. Okay? Then plus, at the end, derivative of 8, which is just 0, so we don't need that plus right there. I'm going to cancel that out, and there we go. So now we have our derivative, so now we need to distribute. We need to distribute this by multiplying everything out. So I'm going to rewrite my f prime of x here, and let's distribute. So negative 7x to the fourth times 2x is a negative 14x to the fifth power, excuse me. We're going to add the exponent, so negative 7 times 2 is negative 14, and 4 plus the 1 up there is 5. So we have negative 14x to the fifth power, plus here 2 times 10 is 20, and we add 1 to 2/5 right there, right? There's a 1 up there, and 1 plus 2/5, well, 5/5 plus 2/5 is 7/5, so we have 7/5 right there. Plus now, 8 times 2x is 16x right there. Fantastic. So now we're going to add the next part. Okay, the next part we need to distribute again. So we have x squared times negative 28x to the third, and that gives us a negative 28x to the fifth power. Multiply the x squared again down here. All right, well 4 plus 4x. Now we have to add 2 to negative 3/5, so it's really adding a 10/5 to that. And when we add a 10/5 to a negative 3/5, that should give us a 7/5 if I remember correctly, and that is correct. So 7/5 there, right? So we have x 4x to the 7/5 power. Now we distribute the 10 across. That's a negative 280 x to the third, and 10 times 4 is 40 plus 40 x to the negative 3/5. So now what I'm going to do, I'm going to combine my like terms and have my highest degree first. Okay, so we write f prime of x right here. Highest degree I see is to the fifth power, right here and there, or to the fifth power. So negative 14 plus a negative 28 is definitely a negative number. I don't see any of the fifth powers there, so it's a negative number. And the 8 plus the 4 gives me a 2, carry the 1, 3, 42, I believe. 8, 42, 1, 3, 4, yeah. So I said, what, 40, 42? Yeah, 42 x to the fifth. That's combining these two right there. So now we have the next highest degree I see to the third power. Okay, and there's only one there, so it's a negative 280. Let's make it a minus sign, x to the third. Got that written down. And the next one here, well, I can either be 7/5, right, or x to the first power, and x to 7/5 is a higher degree. So we combine our 7/5, we have a 20 and a 4, right, 20x to the 7/5 and a 4x to the 7/5. 20 and 4 being the coefficient, so we add them together. 20 plus 4 is 24, x to the 7/5 power, and we can mark these two, showing that we've used them. Lastly, or not lastly, a last positive exponent, we have a plus 16x, the only one that's there, 16x. That's the only one I see x to the first power. My last term here is has a negative exponent, so it's plus 40. And since it's a negative exponent, I'm going to rewrite this because this is my final answer now, to bring basically the variable to the denominator and make it a positive exponent. So we have x to the positive 3/5 power, and there we have it. We have our final answer here, final derivative, f prime of x is equal to a negative 42x to the fifth minus 280x to the third plus 24x to the 7/5 power plus 16x plus 40 over x to the positive 3/5 power. So if I was given this question, We have a classmate. So our classmate, he claims that, parentheses, f times g prime is equal to f prime times g prime. Okay? So he's kind of changed what he thinks the product was. For any functions, here, f and g. What I want to do is show an example. Show an example here that proves your classmate wrong. My classmate, I haven't had classmates in a while, but classmate wrong. He's wrong. All right. So we're going to find an example that shows that our classmate is wrong. We know the real product rule, and it's written right here. If we take the derivative of a function, it's really f times g prime plus g times f prime. So how can we show that our classmate's wrong? Well, if I was given this, let's say an example. Now, there's actually many answers that can show this, prove this. I'm going to show you one way here. If my example was this, if I said f is equal to 2x and that g is equal to 4. So if I said f was equal to 2x and g was equal to 4. So by his logic, or him, or her, whatever, our classmate's logic here, we would say that, well, f times g all prime, right? He says is f prime times g prime, okay? Well, f times g here, f times f being 2x, so we have 2x, times my g, which is 4. The derivative of that should equal each one individually. Derivative of f prime is just 2, and derivative of g, which is just 0, okay? Well, 2x times 4 is 8x, and we need to take the derivative of that, right? The f primes are saying that I need to take the derivative of that. I know it's not like legit math showing here. Well, 2 times 0 is 0. Derivative here of 8x is just 8. So we have 8 is equal to 0, and that's not true. So that kind of shows here that his claim, or her claim, or whoever's claim it is not true. That this idea that f times g all prime is not equal to f prime times g prime individually, because when I showed it here, f times g came out to be 8x, and when I took the derivative of that, I got a positive 8. If I did f prime individually, which is 2x, to be 2, and g prime individually getting me 0, our derivative of 4 being 0, multiply that, got me 0 here. 8 was not equal to 0. Again, I know this little notation here isn't the best way to do it. I really should have said that, f times g is some new function, whatever. But no, that's a little promise that I'm taking the derivative of that. I know some people in the comment sections are going to destroy me and saying, well, you should have written this nicer, whatever. That's what we're doing here. I'm kind of showing that right there, the derivative of that. So, excuse me, that's what we're seeing there. And so we can see by basically taking a claim and showing us an example where it doesn't work, then you say the whole claim is false. Now, be careful. You might have just picked two random, especially if I just picked two numbers, right? If I just took, with no variable, this one being 2, just 2 without the x, and this 4, and I did it, it would have been left and right were equal, fantastic. It almost could not prove, but make the person think that their claim was correct. But you have to find a few of them, or test some different things out here to show that it's incorrect. Because once we can find one way that it's incorrect, that means then this claim is incorrect in general. Okay, so it's kind of easy to prove that something's wrong in that way. And that's it.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.